And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks. So without wasting any time, let's get started. Today's problem is detect loop in linked list, which is marked as a medium level problem. Let's find out what we will be given into this problem and what we have to do. So we will be given the head of a linked list with name as head, and what we have to do, basically we have to tell whether there is a loop in given linked list or not, whether there is a loop exist in the given linked list or not. So what is the loop and how we can detect it? Let's quickly see one by one. So first of all, if we will see this linked list with the node as 1 3 4, so and 4 के बाद it's again pointing to 3. What does this mean? This means basically, look, one has two things. One is like, first thing is this data. One node has two things. First one is this data, and second one is the next pointing to the next node. Okay, so this next node is this 3. Okay, and then there is a node with 4. Okay, all right. Now 4's next, instead of pointing to null, 4 next is again pointing to 3. Okay, 4 next is again pointing to 3. Okay, all right. So basically there is a loop, because now we will be always stuck in this if we will do something like again and again moving forward. So we will be stuck in this loop, because 1 3 4, then again 3 4, again 3 4, again 3 4, in this way. So there exists a loop and we will simply return true. But if, let's suppose, this 4 and this 4's next is pointing to null, so in this way we can simply end this linked list. Okay, so if we can end this linked list, we will simply return false. Okay, all right, and this is what we have to do. Pretty easy thing is this. And if we will see the next example as well, here also we can see head is pointing 1 2 3 4. Very easy. And now 4 next is again pointing to 4 next is again pointing to 1. Okay, so if I will start from 1 2 3 4, and then 4 again, we will go to 1 2 3 4, again 4 to 1 2 3 4, again 4 to 1 2 3 4. In this way it will result in an infinite traversing, and it means there exists a loop, and we will simply return true. So this is what we have to do. A very simple problem statement is there, and I think it will be clear to you as well. So now let's think of the approach one by one. Look, first approach is very simple. I will simply have a set. I will simply have a set of nodes. Okay, set of node. Basically, it will be containing all the node of linked list. All the node of linked list will be containing. Okay, all right, no issues. And first of all, I got the one node, so I will simply store one in my set. This one is not a integer value, but it is a whole node with the next pointer and everything. Okay, then I get 3, so I will store in set 3 as well. Then I get 4, so I will add 4 in the set as well, and we will keep on checking if this 4 is already if this node is already present or not. Okay, and after that again 4, I got 3. After 4 I again get 3. I will check in set if this 3 is present. Yes, 3 is present. It means we are traversing this 3 second time, and we have got a loop, because in linked list, if it does not contain loop, we cannot traverse an element again. Okay, so it's traversing again, it means there is a loop, and we will simply return true. Okay, so very simple it is. We are using some extra space, but the code is becoming very easy with this. Okay, moving on. 1834. So basically 1 is pointing to 8, 8 is pointing to 3, and 3 is pointing to 4, and 4 is pointing to null. Okay, so again we will start basically from with our set, and 1 is present, so I will add 1 to my set. 8 is present, 3 is present, 4 is present. I will keep on adding all the elements to our set, and after that I get null. After that I get null. So whenever in circular linked list we can reach to null, it means it does not contain a loop, because if it contains loops, our linked list will keep on traversing like infinite times, and we will never reach to null. Okay, so it contains null, it means it does not contain loop, and we will simply return false. In this way we have to do. Okay, so the first approach of using a hash set to store the full nodes each time will be very clear to you. Now let's think of the another approach where we are not using any of the space complexity. Okay, all right, so here if we will see the constraints, we can see that um, nodes data cannot be uh, greater than 1000. Okay, nodes data will be always less than 1000. Okay, so if each node we are traversing, uh, can we have negative value? No, we cannot have negative value as well. Okay, so on traversing each of the element, what if I keep make them -1? What if I make them -1? So if we will go here, first one becomes -1, second one becomes -1, third one. So whenever I will be keeping, I will always check if the nodes data is -1. Okay, so again it is changed to -1. Again 4 is also changed to -1, and after that I again reach to 1 whose data is again -1. So basically look, -1, this is present. If any node's value is -1, if any node value is -1, it means it is traversed once and we are traversing it again. So if we have to traverse any node again, it means it contains a loop, and I will simply return true. Very, very easy it is. We are not using any extra space, and we are able to get the solution. But the issue here is कि यार we have changed the original value of linked list. Like uh, changing all the traverse nodes to -1 is changing the original linked list, and we should avoid that. So now let's think of any other approach, but we have already done the two approaches. Okay, all right. Third approach which is coming in my mind is basically a Floyd cycle algorithm. Floyd cycle algorithm in which we take two pointers, slow and fast. Slow will run at one speed, like in 1 second it will cover one block, and fast will cover two block. Okay, fast will cover two block, and we have to tell basically if a loop is present or not. So how we are going to do? Look, 1, 2, 3, 4, and 4 is again pointing to 2. So in this way our linked list is given, and we have to tell whether its loop is present or not, and we cannot use extra space. With first approach which I told, it contains extra space, and we cannot change the nodes data as well. Like I cannot change this to -1 or anything. Okay, all right. So how we are going to do that? Okay, all right. Very, very easy it is. Look, I will have two pointers, slow and fast. I will have two pointers, slow and fast. So basically, slow will run at one step each time, and fast will run two steps each time. Okay, so after SF, this is so now slow will be this, and fast will now become this. Okay, again, when slow will reach here, fast will travel two times, so 3 then 4 to 2. Okay, so this has now become fast. Okay, all right. Now again our small will be updated to 4, and our slow and fast, our false is also updated to fast, to 4. It means both are equal at this point, and whenever we will get slow is equal to fast, it means the loop is present, and we will simply return true. Okay, so this is what we have to do. Basically, if at any point I get node as null, if I at any point I get node as null, it means what? It means loop is not present, return false. Otherwise, take two pointers, slow and fast. Slow will run one times, fast will run two times, and if they match at any point, so it means the loop is present. Okay, all right. I think it will be very, very clear to you. And this is a Floyd cycle algorithm, which is proved and tested, so you can trust on it. Okay, all right. Let's quickly see the code section if it is clear. And please subscribe the channel and like the video as well, because I'm giving my full efforts, and the video is always uploaded by 1 o'clock, 1 a.m. Okay, all right. And so now let's see the code section. Very, very easy it is. I will take two pointers. Slow is also equal to head, and fast is also equal to head. Okay, all right. Now what I will do, while fast not equal to null, and fast dot next not equal to null. Basically, we have to check, because if look, fast will run two times, fast will run two steps at each point. So if at any point I'm getting null, it means no loop is present, because whenever the loop will be present, we will not get null, any node null. Okay, so that's why I'm writing it here. Now Okay, so first of all, what I will do, I will simply update my slow. Slow is equal to slow dot next, and fast will be what? Fast is equal to fast dot next. Okay, and after that, if at any point my slow is equal to fast, it means there is a loop present, because otherwise slow, since look, if one person is running at a speed of 10 and another person is running at a speed of 20, so can they meet each other if the track is, if the track is same, if the track is a single line length, straight line, it cannot meet at any point. But if the track is circular, it can meet at any point. Okay, so that's what I'm doing here. If slow is equal to fast at any point, so we will simply return true. It means the loop is present. Okay, all right. After that, I will come here and I will simply return false. It means loop is not present, because look, when I will come out of this loop, it means ki yaar I have got false, fast as null, or fast dot next dot null, and in either case I will simply return false. Okay, so this is what we have to do, and let me try to compile and run this. Meanwhile, I have made a very cool Chrome extension for you, with which you can watch the problem tutorials here only, instead of moving to lead code and searching it there. So the link is in the pinned comment, make sure you download it, and I hope it will get accepted as well. Yes, it is getting accepted. So you can, if you want to have a proof of it, you can go, you can go through pen and paper and try to debug it by yourself, and it will be clear to you. Okay, all right, so that was it for today. Please subscribe the channel, like the video, and I'm going to see you again tomorrow. Till then, keep on coding and bye.